Now we continue the topic of ROMs navigating speed, size and cost. Last class we see the speed determination, size reflect that permanent storage. Variety of types include mask, cost versus flexibility, and also we see the wide application and block diagram of ROM. Speed, size, cost, trade-offs, all. Now we're going to see the diagram of MROM, that is a MOSgram. A MOSgram is nothing but is a block diagram of MOSgram. Is a type of ROM where the data is permanently written during the manufacturing process. The stored data cannot be changed or erased later. How the MROM is work means, first n-bit addressing input, the ROM receives an n-bit address as input. These address lines are used to select one of the memory locations. With n address bit, we can access 2 power n different locations. Decoder converts the n-bit address into 2 power n output lines. Each output line corresponds to one specific memory locations in the ROM array. The encoder sections contains the fixed data stored during manufacturing. Each of 2 power n connect to d-bit output lines through predefined connections. That is a metal mask. These connections define the stored data permanent data pattern, that is a ones pattern and zeros pattern, and the lost d-bit output. The specific address is given, the corresponding stored d-bit appears to the output. First we want to know the data is permanently stored during chip fabrication. It is non-volatile, that is data is retained even when power is off, used for storing firmware, lookup tables or fixed programs in embedded system. In short, we explain a MOSgram used as a decoder to select one of a 2 power n memory locations based on the input address, and an encoder to the output that stored the d-bit data. These stored is fixed at the manufacturing and cannot be modified later. Next, we move for a PROM versus EPROM. This PROM and EPROM. PROM is nothing but is a programmable read-only memory, and EPROM is nothing but is a erasable program read-only memory. Here a PROM can be programmed only once. When data is written, it cannot be changed or erased. But in EPROM can be erased and reprogrammed multiple times by exposing it to ultraviolet light. And the cost of PROM is cheaper because it can be programmed only once. But in EPROM is more expensive due to its reprogrammed feature. Here storage endurance is a high endurance because data stays permanently. EPROM is a lower endurance since it can be erased and rewritten several times, which wears it out. And construction of PROM is enclosed in a plastic cover, and EPROM is a transparent quartz window on the top of the allow UV light, that is ultraviolet light, for erasing the data. In short, PROM is one-time programmable memory, while EPROM can be erased and reused multiple times. Next, flash memory versus EPROM. This flash memory is based on the NAND gauge. Memory density is higher, it can store more data per area, and the speed of the flash memory is slower access because of NAND structure. And erase type is blockwise, erase large sections at once. And operations is nothing but it supports erase, write and read, and it writes speeds faster than EEPROM. Read speed is slower than EEPROM. Erase speed is faster than EEPROM. Access type is sequential because it reads the data in sequence way, that's a slower. And also cost is also a cheaper one. How it is used means use a program storage, USB drives, SSD and memory cards, etc. Endurance of this flash memory is lower. There is a fewer write or erase cycle possible, and capacity of this can go up to gigabytes. Interface is usually parallel interface. An example, Cypress. And EEPROM is nothing but it is based on the NOR gate, and memory density is lower. It stores less data per it stores lower, and speed is faster access. Erase tab is a byte-wise, and operations supports erase, write and read. Write speed is slower than flash, read speed is faster than flash, erase speed is slower than flash. calculator.